Okay, continuing on with, we were partway through domain and range on page 260. And I did the domain and the range for B and C. So let's do A. So A, there are two ways that we can do it. One is because it is just a set of points, we can just list the points. So I can say my domain, I have to start over here because it doesn't fit. So my domain is the set of points, -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay, and my range in that same notation would be 0, 1, oops, 1, that's a comma, 2, 3, 4. Okay, again, I'm only listing each number once, so my range, my y value can be 0 or 1 or 2 or 3 or 4, and these ones are all repeats, so I don't list them again. Now there is another way to do it. We can do it using this similar notation, and that would be for my domain. So my domain is the set of numbers x such that, and so x is in the middle here, and it goes between -3 and 5, and it can actually be -3 and it can be 5, so it's the less than or equal to, greater than or equal to, comma. And over here, our x and our y were always elements of the real numbers because we had a line and it could be any number along the way there. Here it can only be those numbers. These numbers are all integers. So I can say x is an element of the, oops, no, that's not what I want. It's the element of the integers, okay? Because you can see that if I had to list all of these, I mean, there were 8 of them, 9 of them. That wasn't too bad to list. But if it went from 50 to 300, I don't want to list every single one of those. So I do want to have a way to simplify that. So I can say it's every number from here to there, as long as it's an integer. Okay, and then my range, similarly, it's all the y values, where y is from 0 to 4, inclusive, which means I'm including 0 and 4, and y is an integer. It's an element of the integers. Okay, so hopefully that makes some sense. Let's go on and do this for some graphs now. Okay, domain and range of each of these relations. So for A, our domain is, since this is like a parabola, and I say like because it's not really a parabola, but it looks like it's supposed to maybe be a parabola. But either way, it's continuing up forever, and it's continuing to the left forever, and this one is going up and to the right forever. So we have x such that x is an element of the real number system. And then for our range, we have the numbers y, and we do have a restriction on it that y has to be greater than or equal to -3. So y is greater than or equal to -3, and y is an element of the real numbers. Okay, hope that makes sense. And here, this goes, oh, notice on this one that our variables are actually t and p. So we have to not use x and y, we're going to use t and p. And this value here is -2, and this is 4, and then this is 1 and -3. So our domain is the set of numbers t such that t goes from -2 to 4. So t is greater than or equal to -2 and less than or equal to 4. And t is an element of the real numbers. And then our range is the numbers p such that p is greater than or equal to -3, less than or equal to 1, and p is an element of the real numbers. That makes perfect sense, right? Okay, this one, there's only 3 pieces of information here, so I'm just gonna list them. So my domain here is 1, 2, and 3, and my range is 2 and 6. Sorry for the lousy curly brackets, but I want to go home. Okay, this one we have to actually draw. We have to figure this out. So here's my circle. And I've got the center at -2, 3. So I'm going to go back 2 and up 1, 2, 3. So it's about here. There's the center of my circle. And my radius is 3. So I'm going to come down 3, 1, 2, 3. That's going to be the bottom of my circle here. Oops. So this point right here is going to be at -2, 0. And if I go up 3, 1, 2, 3, I am at -2 and 6 because I went up 3 from the center of my circle. There's that. And then if I go to the right, I'm going to go 1, 2, 3. So this point here is 1 and 3 because it's in line with the center of my circle. And if I go 3 to the left, this point here is going to be -5 and 3. And then I can draw my circle through these points. And so that's the outer range, outer limits of what my values can be. So my domain is the set of numbers x such that x goes from -5 to 1, oops, less than or equal to 1, and x is an element of the real numbers. And my range is the numbers y such that y goes from 0 to 6. It's less than or equal to, greater than or equal to 0 and less than or equal to 6. And y is a real number. Okay, next section. This part is, there's lots of graphs that you can draw for these ones, okay? Maybe. Yeah, I mean, there are lots. Okay, maybe I'll do a couple of different colors. So here's my axes. Oh, that was fun. I don't know why that happened. Okay, there's my axes. And my domain is all real numbers. So I have to have arrows at the end going all the way to the left and all the way to the right. And then my range goes up as far as -2 and down as forever. So the simplest one would be a line that goes like this, and this point is -2 right there, or not -2, +2. This is 2 right here, and then it heads down and it goes like that. So that's like the simplest version. But it could be, I mean, I could have my it could be over here. That has the same domain and range, right? Or I could do one that goes like this, and then it goes up here, and then it goes down like that. Oh, it's only got 1 x-intercept, so I can't do that then, right? Because that's got 2 x-intercepts. Okay. But it could go like this, and it could go like that, and then this goes like that. At some point, this is going to have to end up horizontal, though, so that it doesn't, or it could oscillate back and forth, I suppose, but it has to not go higher than 2, and it has to not go lower than 0. So there's lots of possibilities that I can do for that one, okay? And similarly for this one, I've got my ranges again. Y is less than or equal to 2, so let's make that point right there 2, at 2. So the simplest one here is going to be a parabola that goes like this, like that. Okay, but it could be anywhere. It could be over here. It could be right here. Okay, but it has to go through the y equals 2 line, right? Which is this one here. Okay. Lots of options. Now, why is it not possible to draw a graph which has domain x equals r and y is less than or equal to 2 with no x-intercepts? I'm pausing because it is possible. Hang on. I'm going to pause the video and think about this for a minute. Okay, I'm back. So this is the graph I was thinking of. This is what we call a sine wave, and it just oscillates like waves in the ocean. And I could make it so that it has a maximum value of 2, but it doesn't actually meet the criteria because it doesn't go, it's not any value of y less than or 2. This would be y is between, I don't know, is it 0.2 and 2. So this would have, I can't write on the screen, so just get rid of that. So that one had, the range would have been y is less than or equal to 2 and greater than or equal to 0.2. That was what that was. And that, so that wasn't this. This one is y is anything less than 2. So it's going to have to cross the axis. So this is all x, all real, all x values. And this graph goes from +2 to -infinity, so it must cross the axis, the x-axis. So that's why. Okay. All right. Sorry for the confusion there, but my brain went off on a tangent, and if I edit the video, then I have to I have to stay for an extra half hour while it uploads, so I'm not going to do that because I want to go home. Okay, next page. A high school football team is hosting a banquet to celebrate winning the championship. Caterer sets up a fee of $500 plus $20 per person. So we're going to make a table of values using this equation for a minimum of 100 people. So I'm going to put the 100 people here up to 500 people. I'm going to put the 500 people here. And then I can use any values I want in between. And usually you would break it up by, go by hundreds or 50s or something, but that doesn't quite work. So I'm going to skip to 200. And then I'm going to do 250 and 300 and 350 and 400 and 450 people. So I'm going to come over here and C equals 500 plus 20n, where n is the number of people. So that equals 500 plus 20 times, the first one is going to be n equals 100. And that gets me 500 plus 2,000, which gets me 2,500. So that's what I'm going to put in for the cost, is 2,500. And I'm just going to ask you to pause the video and fill in the rest of the table because I am not going to do all of that with you watching, but I want you to practice it, okay? Okay, so now we've got our table of values, and we're going to plot these on the grid. So this grid goes from 0 to, I need to go to 500, so this has got 5 major divisions. So if I make this 500, then this is 100, and this is 200, and this is 300, and this is 400, and this is this grid is n, which is the number of people. And then going up this way, I just made it easy on myself. I've got to go up to 1,200. If I go up to 1050, I just decided to make this was 2,500. This is 5,000. This is 7,500. This is 10,000, and this is 1,250. And then when it's 500, so each 1, 2, 3, 4, 5. So each increment here is $500. Yeah, that's right. So each one is $500. So at 100 people, it's $2,500. At 200, it's 45. 45.50, so it's here. Oops, there. And then at 3,300, it's 6,300, it's 6,500. So then my 250 is halfway between there, so it's going to be right there. And then 400 people is at 8,500, 75, 8,500. And this one is halfway between. And this is right here, and this one is here. Okay, so there's my dots graphed. Okay. First thing I'm going to ask is, do we do a line through the points? So the answer to this is yes, because of the scale of the graph. Okay, because this is actually on the bottom here is number of people, my domain is not going to be every number from 100 to 500. It's just every integer from 100 to 500, but I can't put 100 dots between here and here without it looking like a solid line, right? So I'm just going to put a line through all of it with a ruler. I'm not going to do that because I'm the teacher. Sorry. So I'm not going to, but you use a ruler, but only because of the scale. Okay, we have to remember that since this is the number of people, our domain is not all numbers. So our domain, we can represent the domain in two ways. We can do a list of the numbers. So we can go 100, 101, 102, ... And then when we do this, we usually put three before and 3 after, so you can clearly see what the pattern is going to be. And then we get to 498 and 499 and 500. We can do that. Or we can say the domain is a set of numbers x such that x goes from 100 to 500, including those points, and oops, it's not x, I'm sorry, it's n. I have to use n. N. So n, where n is an element of the natural numbers. And the natural numbers is better than integers. Integers would not be wrong, but every number between 100 and 500 is in fact a natural number because there are no negative numbers in there. You could also go with whole numbers. That would be fine. Okay. And then the range. Now the range is weird because it is, it's not every number, but it's not all the integers or all the natural numbers either. It starts at 2,500 and then it goes up by multiples of 20, right? Because if we look at the equation, every time you add a person, you add $20 to your fee. So the range is 2,500 and then $2,520 if you have 101 people going. If you have 102 people going, it's 2,540 ... And I'm not going to have enough space to do this. I'm going to continue on the next line. Well, my last number is going to be 10,500. And then I need to subtract 20 from that, so I get 104.80. And then I need to subtract 20 from that, so it's 104.60. Okay, so that I've got the first 3 and the last 3, and you can see that the pattern is it's going up by 20 each time. So that's my range. Okay, so I'm just going to write that down here, that my domain is natural numbers because it's a number of people. And since you can't have, 0.003 of a person, you were restricting it to the natural numbers. And my range, the cost increases, increases in steps of $20 because of the domain restrictions. Okay, clear as mud. All right, that's that. Please, if you have questions on this, just fire me an email over the weekend. I know this was not a very good lesson, but you know that I have a miserable cold and want to go home and sleep. So have a great weekend. See you next week. Bye.